Hi everybody. This is the second tutorial, okay, the solution for the second tutorial for Factory IO. In this section that we're going to call automation tutorials, and as you can see, this one is going to be located in the scenes tutorial 2 from A to B, set and reset. Okay. Basically, it's very similar to the case one, tutorial one, sorry. The only thing is going to have two conveyors, as we were talking in the previous video, and then two sensors, which are going to be photo sensors. This type, which is that one, retro-reflective sensor, okay, and then the reflector or the mirror, if you want to call. So basically, as we were talking, the idea is that the box is going to move in this conveyor that is going to be always on, and then as soon as the container or the case it reaches the beam for the sensor, it connects this second conveyor and it's going to be running until the container reaches the second sensor. Okay, something like this thing. It connects, and when the box reaches the second sensor it stops, right? So how did I do? Well, we're only gonna use 4 items or 4 tags, sorry, which we know are gonna be those ones. 2 outputs for the conveyors 1 and 2, and then 2 sensors, 2 inputs, sorry, 1 and 2 for the respective photosensors or retroreflective sensors. And here I didn't have to this time make my own spreadsheet, just because it's really kind of like easy and short. And so you have here this output 1, which is the conveyor 1, output 2 is the conveyor 2, and then we have the inputs 1 and 2, which are the conveyor 2 star sensor, or if you want to call the sensor A, which is that one, and then the sensor B, or the conveyor 2 stop sensor, which is that one, right? So what do you do for the coding? This example is still really easy. I only need 2 networks, okay, which are network 2 and 3. Remember that the first one is for contacting or communicating between this software of Siemens and the factory IO. So the first network 2, which is the conveyor 1 network, is going to be the easiest thing. The conveyor 1 is going to be always running, no matter what. So right now, the energy is going to go, and the conveyor 1 is going to be always on. Okay? To make it simple. Then we have the other network, conveyor 2. In this case, we're going to put the inputs to, okay? And this way of making this network is following one purpose, okay? And the purpose is that when the container is detected by the input 1, it's gonna connect, okay, the output 2, and when the output 2 is connected, then it's gonna connect here too. So even when the box stops or it finishes being kind of like in between the sensor and the reflector, okay, when the box is here, let's say, even what I want is that this output 2 is going to still running, because if not, what it would happen is that the box, as soon as it runs and it finishes crossing the beam, it's going to stop the conveyor, and I don't want that. I want the box to continue. Okay, so there are different ways to make it, but the simplest one that I was thinking is use this kind of specific structure for the coding. Okay, so the input 1 is going to, so we're going to see here, good, oops, the input 1 is going to be detecting, boom, now it connects the whole thing. Even when it stops detecting, Then the output 2 is still connected until this one it is cut the whole thing, as we can see. So this is the easiest way to do it. Okay, there are different ways. Probably we will see different options in different tutorials. Okay, but as I said, this is one of the easiest. So if you design your own coding, I would say compare with this one and then see if it was more complex, you need more networks, you need less. Really, as I said, this one is not that important. If you didn't know how to resolve that problem, well, here is the option. Okay, remember these photosensors. Sorry, these photosensors, they're already in yellow because they're already on. Remember that this type of retroreflector works in the opposite way. Okay, it is normally closed, so it sends the energy when it doesn't detect nothing because of the reflector, but when it does detect something, it doesn't send the current to the PLC. So it has to be the opposite. If instead of this type of sensor, we'll be using, for example, a diffuse sensor, this one is the opposite, it's normally open. Okay, so in that case you will have to put the opposite thing here. You have to put it as a normal open, and this one should be normally closed, which is the opposite as these kind of sensors. Okay, so I would say try. If you didn't know how to solve this problem, try. And we are going to, if you have any questions, just let me know, write me an email or a comment, and then I can kind of like discuss with you how to solve these kind of problems. Okay.